Hi. So tonight I was going to talk a little bit about getting to grips with PHP on Kubernetes. To start, give some background, some introduction. I began working with PHP 15 years ago, but got my first full-time job as a PHP developer with the business studies and e-commerce back in 2006. I started looking a bit more at the operational and kind of encompassing components that make up system architectures and that type of stuff, probably about 8 years ago. But I still use PHP, and I've been using Kubernetes now for a few years with a couple in production. So I thought the best way to approach this was from a sort of a situational perspective. So we have a situation. We've got ourselves a Lumen service that we'd like to host, and we've got a few very basic requirements for that hosting. It's just a standard Lumen service, nothing crazy, nothing special, and we don't really have any, I guess, requirements on where it needs to run. We do have some requirements about what needs to be available, I guess. So we need to be able to scale relatively easily. The service must be, or it needs to be able to run resiliently. It should be always available. And for the application to function then, we need to keep in mind that it should be stateless, and it could or should be run from a read-only file system. So then we look at Lumen itself. We've got our basic structure, just the standard bootstrapped, which I'm sure most of you are familiar with. We'll add a few bits and pieces to begin with. So our initial commit, much like every initial commit, has a few little bits and pieces. We know we're going to develop this locally, so we're probably going to use Docker just because it's easy and there's a lot of benefit we can get and a lot of time saving. So we don't have to worry about dependencies on laptops or whether people use Mac or Windows or Linux or anything like that. And because we're probably going to be dealing with some data, so we'll chuck in a MySQL database over there. That means that we have 3 containers. We've got our database, our PHP FPM, and our Nginx container. To simplify it a little bit further, we'll add a make file just to give some common commands. So a little bit of extra detail. In a make file, I tend to add a few standard targets to every service, especially in a service-oriented architecture or microservices, if people want to use that term. The idea being that I can go into any service and run makeup, and the containers will be available. And if I'm finished, I can just run make down and then stop. The next one is to have a shell. So I wouldn't have PHP installed locally. If I need to run any artisan commands, I would first make up so my containers are running and then make shell. So then I'm presented with a shell that I can run artisan. So the idea is that we encapsulate all of these types of common commands into one simple interface that our team can work with quickly, and that way they don't need to worry, things just work. So then we have Kubernetes. Really, because we've already started off with Docker as a core component, we just need to translate from our Docker compose. We'd start off by looking at our 3 containers, where we would translate these into pods made up by deployments. So a pod is basically just a Kubernetes representation of a container. Of course, there's more to it, but at a very basic view, that's all it is. Then a deployment defines a method by which pods are executed. So we can say whether or not we need to have some sort of network interface or that type of thing. So for our 3 containers then, we would have 2 deployments, one just for Nginx and PHP and the other for MySQL. The key point to sort of relate back to one of our requirements then is that pods are ephemeral. They can disappear, be recreated, run anywhere, and we don't really know about that. Kubernetes manages that for us. And then it comes time to look at the deployment. So at a very, very basic view, we have a definition for Kubernetes to interpret. We specify that we're looking at a particular version of the Kubernetes definitions. We say that we're working with a deployment, and then we provide a spec or specification. And it's just YAML, really. For the containers themselves, which sit within that spec, we can specify them as a list, and that way they work together as a single unit, but separate containers. So we have our first app, which we can have whatever image and tag we're after. We can add environment variables, whatever we need to do, and then we also add our Nginx container. And this way we use a volume mount, so that way we can specify our actual Nginx configuration, because there'll be things we need to add in about mounting or working with IP whitelistings or anything, whatever you need to do. To then interface to our Kubernetes cluster itself, there's a tool provided called kubectl. So it's the standard CLI tool that gives us direct communication capabilities with a cluster. So when we're looking to make changes or get any sort of visibility, we use kubectl to run this deployment. We can use the kubectl apply -f command. And -f here is a switch that accepts the file or path that you would like to apply. If we want to see what's already running, we can request the pods from our Kubernetes cluster. So once we've got our deployment running, we then need to think about health checks and accompanying sorts of bits and pieces. So for health checks, it's the sort of thing that you would normally have with a load balancer, where a load balancer needs to know which services, which hosts, which EC2 instances are available and accepting or ready to accept requests, so that way it can forward the traffic through. So to make a health check nice, it should be small and non-interactive and really non-intrusive. It's good to structure the responses just to make it a bit easier to work with if we ever need to look at the content or do anything further with it. So for an example here, we would just have a /health path, and we provide a very small JSON response. In a Kubernetes world, we then have a couple of additional checks. So we can look at individual attributes of containers and give Kubernetes a bit more of an idea of the state of how our pod is running. So we have a liveness check, which lets Kubernetes know that we're still up and running and everything is good. And then a readiness check to let Kubernetes know. So if it's scheduled a new instance of the pod, Kubernetes will use the readiness check and wait until everything is good before it starts to send traffic and use it as a part of the cluster. So for our readiness check, we would do something slightly different to the standard health check. We might say, make sure that our database connection is still available. And if we have it, we might check Redis and whatever else we need to do. So we can be a little bit more strict about failing for the readiness check, just to make sure that everything is still good. And then again, to make it a bit nicer, if we ever need to look at it in the future, we add this information into the response. So once we've got things up and running, it's all good. We're serving traffic, accepting requests, all the rest of it. When we want to sort of get some visibility here, we want to see a little bit more. So we can get just pods. We can make sure that Kubernetes keeps up to date with it, keeps an eye on it, make sure it's still running. And then we can get a bit more information about each of our individual pods if we ever need to look at it. So we've got the pods, we've got some PHP APIs. How do we then open this up to actual end users? So if we have multiple pods, we need to group them under a common name. In a Kubernetes world, we use a service to do this. And the service here is essentially a load balancer in a traditional sense. And when we're ready, we can then add an ingress to this service to expose it outside of the cluster itself. So we combine them to make it smooth, essentially. So for the service, we have another YAML definition. We specify the version of the API that this kind exists within. And for a service, it's called a service. We provide a name that we can use to access this service. So within the cluster itself, if you've got other applications running and they need to access this particular service, you would make a HTTP request to our -service -name. For the service itself, it has its own spec, and that's where we can specify our ports to map from the pod itself to the cluster for the other services to access. Then for the ingress, it's another definition. This time, the ingress itself is part of the extensions set. And again, it has its own spec with a series of rules. For these rules, though, we get a little bit more flexibility and we can be a bit more specific about exactly what we want to do. So we can go so far as to say we want to have an ingress on a particular domain or a subdomain, and we can go down to the level of saying only a certain subpath should then route through to the particular service that we've set up. With Ingress, there's a lot of options that we can pick. One of the common traditional ones is to use an Nginx Ingress. There's plenty of other ones depending on what sorts of routing options, whether you want to have any sort of SSL, if you want to do any sort of different load balancing techniques rather than just round robin. But usually they're quite simple. A lot of them support multiple domains or subdomains. Most of them support subpaths as well. And often you can chain ingress with other services to accomplish what we would traditionally do with middleware. So commonly I would use an OAuth proxy that sits as a part of my ingress to place authentication in front of my services without my service having to do any sort of integration itself. So if we have multiple services then within a cluster, we can use these service names to communicate with each other. We don't have to know any sort of IPs or domain names or any other sort of traditional identifier. We just have a service. Kubernetes has its own DNS management that runs internally as a part of cluster, and it manages all of that for us. We don't need to worry. So once we've got this up and running, we want to progress. We want to change. We've got new features. We've got product managers breathing down our necks. We need to make some changes. So the first way that we can do this is to replace the existing image. We have pods that have this particular image and a tag. We can essentially just tell Kubernetes to set the image to something different. And that way we can replace the tag with v2 if it was a v1 before, and then we delete the pods, and Kubernetes, when it builds, when it runs new pods, they will run with the new image instead of the previous image. There's a few interesting parts that complicate this. Everything within Kubernetes itself is asynchronous. So when we say we want to delete a pod, it says, okay, done, deleted, but it's still actually in progress. There's connection draining, there's various other sorts of concerns that go on that we don't even know about. So there's also additional commands then that kubectl provides that we can use to keep an eye on this type of thing. So there's a few, I guess, other trains of thought when it comes to deployments as well. One of the other ways is to go back to our original definition and actually change the, say, the tag for our deployment, and then we run the same kubectl apply -f, and that accomplishes the exact same thing, but it also means that our deployment definition is now the exact same as what we have running. So if something disastrous happens and we need to rebuild from scratch, our definition is already up to date with what is actually running. It also means that if we need to change any of the definition, if we want to add more environment variables or change resource assignments, volumes, whatever it might be, we can do that as a part of the one process. It means that we don't lose track of the source of truth. One of the common requirements as a part of deployments then is notifications. So we want to know, okay, our release is done, let everybody know that version XYZ is now up and running. So with that rollout status, we can block and we can wait. And once everything is successful, we can send a Slack message or email, whatever it is that we need to do. Much like everything else, the good thing is people have already worked on this before, and so you've got a lot of these options already available. Yes. Deployment action. So often when we make a deployment, we've got things that need to happen outside of our actual running code. Most commonly, database migrations. So we need a way to be able to execute the migration. The good thing is, in a deployment, we have our list of containers, and as a part of that, we also can specify a list of init containers. With this, we can, say, run our artisan migrations, and we don't really have to do anything crazy. We don't have to add more images. We don't have to write our own scripts. We just add this little bit of extra. So an init container runs before our pod is actually deployed. So we can have our migrations run, and only if they complete successfully will the deployment complete. So if the migration fails for whatever reason, it may not roll back, but at least the new version won't actually be deployed. The key point then is to make sure that everything is backwards compatible. So if something does go wrong, or if things take too long, then there might be some synchronicity issues. So if you're deleting or dropping tables from your database, and you need to make sure that your current running pod doesn't try to access those because it's going to fail. There's a few other things that some people do as well. Search index updates. are a common one for that. So an init container is still a nice place to do those, but the things that take more than, say, a few minutes, it's probably better to think of a different way to do that. Init containers, because they kind of hold up the whole process, they're not the best place for things that take a long time. So we probably should spend a bit of time thinking about our architecture and how we're going to approach these things, and perhaps split them up a bit more. So then what if we needed some storage? Let's say we needed to handle some file uploads or caching or something else where we need writable storage. So Kubernetes provides us with PersistentVolumes. It's a way for our deployments or pods to be able to request some sort of disk space that they can work with. There's a few providers that are built-in, but there's plenty that you can add in yourself. This is especially the case for particular providers, such as using Azure or Google Cloud or AWS specific data stores. Oops. The one problematic part to this is that PersistentVolumes are attached to a node inside of a cluster. So if you have multiple nodes, you need to add the same volume for each, but each of those volumes are independent of each other. If you need a single shared file system, then a traditional NFS or some other sort of network style storage is probably more suitable. So with our claim then, we have another definition. We say we want to make a persistent volume claim. We give it a name, and for here we would say storage claim. We can specify that we want to be able to write to this particular storage. The storage class name is the configurable communicator, I guess. Like GP2 is the default. It's how you can request, say, an EBS volume inside of AWS. If you were to add a new storage engine, say for something with Google Cloud, then you would change this to be GK or something suitable. And then we can also add our request of exactly how much storage we're after. So then when we want to use this, in our container spec, we would specify the volume mounts where we can say, okay, we have our storage volume. We know that from the persistent volume claim. And we want to say we want the container to be able to use that volume at that path. We then also specify here that we wish to bring in this persistent volume claim as a part of this deployment. And so if there's multiple containers, we can attach the same volume to each of those containers. What about if we wanted to run some scheduled tasks? There's maybe cleanups, maybe there's daily emails or something. So we have cron jobs. Pretty much just a normal cron job or cron type entry, the same syntax or the same syntax of the cron part itself, but just in a Kubernetes style YAML. Like everything else, and like a hub deployment that we've already been through, we specify our pod spec that will then be executed roughly as the cron tab specifies. Kubernetes manages it with its own internal scheduling. So every X amount of time, your pod will be spun up and the command executed. With everything else, we should keep in mind that these things need to be idempotent. So every time they run, we expect either the same things to happen or we gracefully move on if something's not quite right. The cron job definition itself then, much like the rest, we have a kind of cron job. We can specify how much we want to keep history. So each time a job runs, we can keep a record of that so we can go back in time and we can see output from failures. Maybe we need to fix something up. We specify our schedule, which is the usual cron tab format. And we have our job template that contains the spec for our pod that we wish to run. Additionally to cron jobs, we might have one-off jobs. So these might be, say, just a non-scheduled, long-running task. It might be some sort of massive reindex of a database or whatever we might need to do. We might just need to run this once and we never have to think about it again. So one of the common ways to get around the init container problems is to combine it with a job during the deployment. So before we actually execute our normal deployment, we would run a job. It might be update the Elasticsearch index. And then once that job completes, we execute our deployment. So everything is now up and running. One of the problems with a job is that it can only be run once. Once it's finished, we can't rerun it. So if we need to rerun the same one, we need to delete the old one and then create it fresh. Good thing about having the YAML handy though is that's trivial to do. And so we have a job definition. We say that we have the kind of job. We have a template spec where we have our containers. In this case, I just thought it might be nice to see the PHP info inside of the Alpine container. We can say that the container should never be restarted if it fails. And if there is failure happening, there's a backoff limit that Kubernetes won't try to start it more than this number of times if something's not quite right. So once everything's running, we've got a deployment process, we've got new features. Now we need to get some visibility into how things are actually going in there. So that leads us to metrics and logging. Usually I would recommend for a Kubernetes world to use Prometheus as the metrics gatherer. It handles most of the Kubernetes ecosystem natively or with a minimal amount of effort to configure. There's a lot of language SDKs and libraries for extracting metrics from services, including PHP, which is quite simple and easy to use. With logging, however, everything kind of just works in a, I guess, a standard logging kind of a way. All pods and node logs are captured within the node itself, and we can, I guess, take those logs and push them wherever we would like to. It could be an external service. We might run our own elk stack. There's so many options, and it doesn't really matter. So for Prometheus, then, we would say we want to bring in some of the Prometheus classes. We create an adapter, and in this case, as we're running FPM, we can get away with just using in-memory. We set up a registry with that adapter. We then specify that we're looking to just render text, and we can then call the Prometheus lib to generate a dump of these metrics. And if we're in a, if we add this as a part of our, or add a route to this script, we set our headers for the content type and the rest, and just echo the result. So then within a Kubernetes cluster that's running Prometheus, these metrics can then be collected and we can graph on those and set up alerts and whatever we need to do. To have Prometheus discover our pods and containers, we use annotations. So with the same cluster running, Prometheus already scans and looks for particular annotations, and as long as we add them, we don't have to worry about it. For the annotations themselves, we have our deployment, the same as before. We add to our spec. We set some metadata on the template itself, and we add the prometheus.io/scrape annotation and then the path and the port. So this way, Prometheus looks at all of the pods within the cluster for the scrape set to true. And if it does, if for each pod that Prometheus finds that has that value there, then it will look for the path and the port to call on the service that's exposed from that deployment. So the next part then is to simplify this a bit more, we can package it all up with Helm. And so Helm has this concept of charts, where they're essentially a group of these YAML files that are templated to make it a lot nicer to work with. We can create our own and add in each of the components that we're after, and we then make a set of values that simplify using that chart. So we can set up our particular environment. So if we want to deploy for a staging or a production, then we only need to change a few of these variables. We don't have to rebuild the chart every time. So a basic chart has not many files. We have the chart definition itself and values YAML, which is where our defaults get stored. Then we have in a templates directory each of our actual component definitions and the helpers. The helpers provide, I guess, like functions that can be reused throughout the template files. So for our own chart then, the biggest thing that we can get away with by using our own chart is using subcharts where we include other Helm charts. So we can take the existing MySQL chart and we can just subchart that as a part of ours, and we then don't have to define any sort of pods or storage or anything just for MySQL. Somebody else has already done that work. Yeah. So a few things that we want to keep in mind when we are defining our chart, and to keep some very common parts quite flexible. So resource allocation and volumes and environment variables, the sorts of things that people might want to tweak when they do this themselves or when they run it themselves. So if you're running in a very small cluster, you might not allocate as much CPU or as memory as somebody else who's running a much bigger cluster. We can give our chart a name, and we add some details on how people can use it, how they can tweak it, how they can contact you if they need some help, and then we can publish it. So for the MySQL chart then, we add a requirements YAML where we can say, okay, we want to use MySQL. The version of the chart is 0.15.0, and it comes from the repository stable. So Helm has its own stable repository, which is just a Git repo that gets published onto one of the Google user content, whatever that. Yeah. So that way you can use a bunch of these charts without having to do any sort of crazy configuration of your own. One of the other topics that tends to come up then is serverless, so Lambdas and that type of stuff. So in Kubernetes, then you can use existing tools that provide a platform for you to be able to leverage these concepts yourself. So one of the tools is called kubectl, and it already supports PHP. So you can just have a single small PHP script and run it as a Lambda inside of a cluster. I feel like if you've already got some Lambdas that you use as a part of your application, this is probably a good kind of a way to start to get into using Kubernetes if you don't already. And if you have a lot of big chunks of code and you much prefer to leverage this type of Lambda concept, then kubectl is probably going to be quite nice. For me, though, I find that it's probably just overcomplicating things. You're already running a Kubernetes cluster, so managing functions on top of that is probably only going to make it worse. One of the other concepts, though, is to have a bit more of an event-driven flow. So one of the tools that makes this quite nice is called Brigade. So everything inside of a Kubernetes cluster, when there's changes, when there's state updating, when people are doing things, events are being thrown. So Brigade gives a way for you to be able to tap into each of those events and do things or log actions or just whatever you'd like, really. So you can build up your own scripts using these tools. We could also just look at some different methodologies on being able to accomplish potentially some traditionally difficult things. Oh. Any questions? Yeah.
About the data, and you use one of job for that, or is something different?
Yeah, so if you had some data you wanted to add to your database, or if you're deploying your app for the first time, you want to add some data, a job is perfect for that. You'd be able to set up the configuration. Say if you have like megs or gigs of SQL in an S3 bucket, your job then runs a command to pull the data down and just push it in to the database. Yeah.
So for your images that you're using in your Kubernetes, what's your process for building them?
There's so many. I had to make a couple of changes to one of my kind of shared images yesterday, and I just did it by hand and just pushed it direct to Docker Hub. But often I tried the Docker Hub's automated builds, and they're quite nice, but they're very slow. They manage their own Jenkins clusters, and they fall over, and they can be a nightmare if you rely on things right now. Some of the popular images can be quite delayed as well, so they're a good indication of just do it yourself. I've had a lot of success in the past using Circle CI and then using the Docker and Docker to build an image and just push it to Hub. It's quite straightforward. I don't have any code samples of that one, but I've been thinking about sending my own pipeline up again. So in development, I'm running Ubuntu at the moment, but previously I've used a MacBook Pro, and Docker for Mac about a year ago, I think, brought in as a part of their Edge version the ability to run Kubernetes locally. And I tried that out, and I had tabs in Chrome just disappearing. It was just, the resource usage was so much that just random processes were being killed. And so I had to turn it off again. I would like to use Kubernetes locally and develop that way. So it's much more specific to seeing exactly how things are running and making sure that what I'm developing on is exactly right. But for the most part, unless you're dealing with a lot of services that you have to have running, Docker Compose is probably fine.
But there's the Cube as well, right?
Yeah, I have played with Minikube about 2 years ago, and I had mixed success. I've been meaning to try it again recently. Sorry? Yeah. I've meant to look at it again because I'm sure that there's been a lot of improvements since that time. But if it can be run without killing tabs in your browser, then it's probably worth a shot.
Does anybody use it generally?
They improved it a lot about 9 months ago. I remember having a lot of issues, especially with Node and Ruby. Yes. Yeah, the number of files meant that 2 layers of virtualization was just a nightmare, and a Mac can't handle that. No computer can handle that.
Good question. So Kubernetes kind of, if you may say, advertises itself cloud agnostic. Or do you have an experience of how cloud agnostic?
Sort of. So I generally run my own Kubernetes clusters in AWS. I've used both Rancher V1, V2, no, not V2, V1, V1.6. And then in recent times, I've been using kops to bring up Kubernetes clusters. They work fine for the most part. If you have to change some very low-level details and configurations, Rancher may not be your best bet, but in kops, you can change absolutely everything. For the hosted services, so EKS and GK, so AWS, EKS, Google's GKE, and Microsoft's Azure Kubernetes, I've not tried them. Mostly because I know that there are some limitations that I've needed, but I think for standard stuff where you just have, say, a bunch of charts and you've got some web traffic you want to serve requests for, I think it's probably fine. Like, that doesn't matter really. The good thing about all of these YAML files and then Helm charts is they don't care about your cluster. They just need a cluster.
Well, you mentioned that you use to run some migration, something like that. You probably know that when you deploy several references, it continues to run for each port, each copy. So I just wondered, do you know a way to run some kind of migration or something like that only once during the deployment? It was my first question. And second question, this is you're using PHP and MySQL, and first you are running migrations, you need to be sure that MySQL is already up and running and ready to receive connections. So do you know something better than get another wait for shell script?
So probably the second question is probably easier to knock off first. My biggest recommendation for databases is don't run them in Kubernetes, or don't run them if you don't have to yourself. Use RDS or anything, just don't spin up your own server and start MySQL. You're probably just asking for trouble if you're doing that. Then you have to get a DBA and a sysadmin to look after it. The wait scripts are still handy for development and CI and integration testing. I've got about 4 different versions of the wait.sh file, but I've also used NC if it's available in the container I'm running, so I can just use ping out to the host and inside of a while or a for loop, and that'll be fine. For the init container, one of the ways to get around having multiple instances attempting to run at the same time is using some sort of shared lock. I've had success using S3 because I kept state for my environment inside of an S3 bucket anyway. So when I would run a deployment, one of the first steps would be to retrieve that state, which would then leave behind a lock file. And so then if any other init container also got that log file, it would not proceed with its work. There's also memcache or Redis or any other way to sort of come up with a locking mechanism, but when you're having that sort of an issue, that's probably the easiest way, or that I know of at least.
Would you potentially run job API for
Yes, I've heard of that as a part of the build process, run your migrations. Yeah. That's, yeah, again, with the idea of using a job instead of an init container, that is certainly doable. Yeah.
In a Kubernetes cluster, when you deploy a new version of the deployment, how does the health check work? Like, does it try to keep the container, or sorry, the pod?
Yeah.
And when, if the pod returns like being unhealthy, does it shut down and try to start again, or how does it work?
So with the health checks, I guess that's part of where the liveness and readiness check comes in as well. So if your pod is starting up for the first time, you can set a grace period. So if you're running an Elixir app, for instance, it's an umbrella application, there's 15 processes running inside that umbrella. It's going to take about a minute and a half maybe to boot. So you know then for your deployment for that pod, you set a grace period of 90 seconds. And that way Kubernetes won't even try and see if it's ready until after 90 seconds since it started that container.
But what if it starts, it really shuts down and tries to start again the next period, or?
Then there's more options where you can say try 5 times or wait 6 seconds between each try, and that's the same for.
Because then
yes.
then in the code of deploying like foundation or whatnot, your health check can be dependent on like where the database all the migrations have been done. And if the migration part of your database like Lumen application database migration folder, and the new pod versions will always be unhealthy until the migrations are applied. And then you just restart enough times and suddenly the code starts working, the new version of that, the single migration.
That's one of the reasons why I like an init container, is the new pods won't actually be deployed until the init has run. So you don't have to worry about your pod checking to see if things are ready.
And then shutting down.
Yeah, and so then if you do the job work, like run a job, perhaps as a part of CI or as a part of the deployment process before you change your deployment, you can then wait for that job to finish, then you run your deployment, and your deployment already has everything done. If there's no need for an init container, you do that outside of that process.
Thank you very much, Allan.